right, folks. Well, we appreciate everybody that got checked in on the early check-ins there. Let's say, before we get started, I'll remind everybody that is listening or connected via Zoom that we do have a drawing tonight. After we get all the late check-ins done, there is going to be a drawing for a prize giveaway. So please don't be hasty and jump out too soon. You might miss out on something good here. So this looks like a record, 21 early check-ins. Man, that's good. All right, so we're going to go ahead and get started. This is QST. Good evening, everyone. This is KI5SIJ. Welcome to the Crossroads Ham Radio Club Tech Net number 2 on the W5LCR linked repeater systems. If anyone has any emergency or priority traffic at any time during this net, please call break, give your call sign, and the net control operator will recognize and handle your traffic. Not hearing none, we'll press on. This TechNet meets on the first Wednesday night of every month, starting at 8 o'clock local time, and it's simulcasted on the Crossroads Ham Radio Club linked repeater system, spreading out throughout the South Central and Southeast Texas. We employ a variety of technology options, allowing connectivity to the system. For a complete list of the linked repeaters with the frequencies, offsets, tones, and supported modes, please visit our website at CRHRC.org. Also, you can find the TechNet information located at technet.crhrc.org as well. Tonight's net is being logged in real time over the internet using NetLogger, and I'd like to thank Darren, KI5HVF, for being the NetLogger tonight. Thank you, Darren. And if y'all are on Zoom, you can see him up there. And he's doing a great job for us getting everybody checked in. I'd like to give him thanks, and thanks for helping me with all that tonight. For tonight's TechNet session, we'll be sharing information over a Zoom session. If you have not already done so, you can connect in by going to zoom.crhrc.org and logging in. Be sure that when you log in that you change your name and put your call sign in the name so we know who you are. To give us as much time as possible for the presentation, questions, and discussion, please note that we'll be handling check-ins a little bit differently than we do on our regular weekly nets. There are 3 different ways to check in. The first way to check in there is to check in by NetLogger, simply by connecting to the Crossroads Ham Radio Club session in the NetLogger app, and we'll see you appear in the Monitor tab. Once we see you in NetLogger Monitor tab, we'll go ahead and automatically check you in for the net. All right, the second way to check in is to log in through the Zoom. Connect via the Zoom session. The Crossroads Ham Radio Club TechNet Zoom session can be found by going to zoom.crhrc.org. Once in the Zoom session, as I previously mentioned, make sure you type in your call sign in the chat, followed by check-in, and we'll see you there and get you checked in. And third but not least, the last way to check in is for those that have not connected via NetLogger or Zoom, we'll be taking late check-ins on the repeater system after the general Q&A session. During the duration of this TechNet, all Zoom mics will be muted. The Zoom session is being recorded and will be posted on YouTube for your reference purposes. All Zoom participants can pose questions, conversations, and discussions inside the Zoom chat via text, where other subject matter experts can assist while the net is simultaneously taking place over the air. Once the TechNet has completed, all mics will be unmuted. Again, my name is Joshua, and my call is KI5SIJ out of Manville, Texas. I will be your net controller for tonight's monthly TechNet session. Tonight, Tonight we'll be having a presentation presented by Chris, W5CUY, regarding antennas. After the presentation has concluded, the Net Control will ask if anyone has any questions or comments regarding this specific topic. Once all questions regarding this presentation have been addressed, then the Net Control operator will open up the net for any general related tech questions regarding amateur radio. At this time, we'll go ahead and hand over the net to W5CUY Chris so that he can present his presentation. The floor is yours, Chris.
Well, good evening, Josh, and everybody on the net. Thanks for the opportunity here to do a presentation on antennas for the club. Bill K5LK, I'm trying to do the screen share thing, but it says it's disabled by participants again like it did yesterday. So we'll get that fixed here shortly, everybody, and we'll be right back.
Right down, Chris. Sorry, K5LK.
How's that? I can't see what y'all can see.
It's going great. Thanks.
Appreciate you. All right, folks, so we'll go ahead and get started. Welcome, as Josh said, to the CRHRC Tech Net number 2. My name is Chris, W5CUY, and I'm in Louise. And in this presentation, I'm going to be covering UHF, VHF, and HF antennas, as well as basic antenna theory review. This is part 1 of a possible of several part series. If there's anything specific that you would like to dig deeper into in future editions of the TechNet, please let the CRHRC Tech Net team know, and they'll be sure to include that in future antenna presentations. The TechNet team can be reached via email at technet@crhrc.org. A little bit about myself. I passed my tech in general as my intro into ham radio in November of 2018. In 2021, I upgraded to amateur extra. My primary interests in ham radio are working DX on HF and HF contesting. I am by no means an expert on antennas, and I don't claim to be, but I'm very passionate about antennas, antenna theory, and building antennas, and I want to share some of that with you today. Antennas are just antennas, right? No, they're not all the same, though. Whether you've been thinking of adding a new antenna to your farm or trying to figure out what would work best in a certain scenario, there are several factors to consider when choosing the right antenna for your needs. What may work best for local repeater rag tube might not work so well as an antenna to work satellites. What compromises do you have at your QTH for considerations such as like space and height? Well, we can talk about compromise. We'll touch on the original compromise, the compromise of 50 ohms. The history of the 50 ohm impedance goes back nearly 100 years to the late 1920s and early 1930s, when the telecom industry was in its infancy. Engineers were designing air-filled coax cables for radio transmitters designed to output kilowatts worth of power. In the research for the best characteristic impedance, a compromise of 50 ohms was agreed upon. This impedance would allow for the best mesh of attributes and you would expect from feedline. The researchers discovered the impedance best suited to support maximum voltage carrying capacity was around 60 ohms. The best power handling characteristics came in at around 30 ohms, and the impedance to support the lowest signal attenuation was found to be around 75 ohms. That may sound familiar, and we're going to talk about that later. Just like optimal feedline characteristic impedance, all antennas are compromises as well. Well, all antennas except for this one. Here's an isotropic radiator. This is the perfect antenna, and this is how we measure them. Everything that we measure is compared to a standard, and antenna performance is no different. What you're looking at here is a radiation pattern of an isotropic radiator in free space. Isotropic radiators have unity gain, which means they have a gain factor of 1 in all directions over the surface of an imaginary sphere. I know it sounds complex, but that gain factor just equates to 0 dB. No gain, no loss. It's just 0. That's the baseline. This is the typical standard that antennas are measured against. Gain listed in dBi, when you're comparing to an isotropic radiator such as this, are always a larger number than gain listed in dBd. This makes an antenna's product performance sound more impressive, and that's one reason why antenna manufacturers list gain in dBi, even though comparison to a simple dipole such as dBd is more meaningful and practical of a comparison. Well, where can we get gain? Well, one of the best places I've found to get gain is from DX Engineering. They sell it in a kit, and it comes with, yeah, that sure would be nice, wouldn't it? But unfortunately, that's not where it comes from. Think of gain as squeezing antenna performance in a certain direction while taking gain away from other directions. You cannot create gain, you can only direct it. Gain is an important factor to consider in an antenna based on what you want to do with your antenna. Here's an example of what gain looks like on a plot. These plots are for an 80-meter horizontal delta loop. The image on the left is an elevation plot, or what radiation patterns look like from the side view of the antenna, and the right image is an azimuthal view, which is what patterns look like from the top down. As you can see, there are areas in the pattern that have more gain than other areas. Most radiation plots will look cleaner and more even than this. I modeled my actual antenna at my QTH. It is not installed perfect due to location of tree supports, but this antenna far surpasses my expectations on performance. Remember, every antenna is a compromise. And remember that gain plot lobes are very similar for both transmit and receive. Where you have more gain on transmit, you'll also have more gain in receive. So the angle of that gain is important as well, and that's called takeoff angle. So let's look at this radiation pattern of the delta loop again. In this example, the takeoff angle is the angle in which RF departs from this antenna. You can see from the plot that the angle in which radiation leaves this antenna is 22.5 degrees. That's 22.5 degrees off the horizon. This is an acceptable angle if your goal is to work stations in that direction. Now let's take a look at some antennas and some practical applications of this. Here on this slide, we have some VHF and UHF antennas that are typical that we see. Everything from tape measure Yagis to quarter wave ground planes to antennas designed for satellite work. Before we move to the next slide, though, I'll remind you that this is Chris, and my call sign is W5CUY, and we're in Louise. So if your goal is to work local repeaters on FM mode, here's some things to think about, because most repeater antennas are collinear arrays that are made up of folded dipole antennas. So these arrays have many configurations and patterns, and typically these antennas are configured to be as omnidirectional as possible and with a slight negative takeoff angle. This is because you want a repeater to hear equally well in all directions. Repeater antennas are usually installed on elevated structures, so the slightly negative takeoff angle is beneficial to to aid in receiving stations closer to the location of the antenna. Repeater antennas are vertically polarized, so your antenna should be as well. Cross-polarization attenuation can be as much, if not more, than 40 dB, depending on the antenna and the environment. That's a lot. If you enjoy working CW, sideband, or digital modes on VHF and above, you will most likely be looking for an antenna that is horizontally polarized. Compared to HF beam size, HF high-gain VHF and above antennas are smaller and are easier to configure into an array. These antennas, especially when configured in an array, are extremely sensitive in the direction they are pointed. There are a lot of challenges at making long contacts at these frequencies with these modes, and having antennas configured in this way makes up a lot for a lot of those challenges. You can see in this picture at the bottom right, this is a few good examples of some nice array setups. These look like these are 2-meter arrays, and that's some serious gain there. Another thing to remember with VHF and above is height is might. If you're looking to work the birds, to do EME or decode weather satellites, you may be inclined to use an antenna whose takeoff angle is closer to 90 degrees in elevation. As long as everything is working as intended, most satellites and celestial bodies will never be near the Earth's surface. Funny how that works. Most of these antenna polarizations is not critical because they're circularly polarized antennas. Satellites spin and tumble and do all kinds of cool stuff, so antennas are constantly changing polarization. The antenna on the left, this one here that you can see on the tripod, is a dual band handheld option for working satellites on the go. The antenna to the right of that is a quadrifilar helical antenna, and that particular one is designed to receive NOAA satellites on 137 megahertz. Next to that is an M-squared egg beater antenna. Those two are specifically designed for straight up 90-degree takeoff angle on receive because they're intended reception areas directly overhead. If you look to the right, that's another impressive array there, and that belongs to Finn Jensen, who's the silent key as of 2011. He was a Norwegian ham that built this setup, and this is a massive array. This tree in the front's kind of blocking part of it, but there's 32 17-element Yagis on 2 meters there, and it took him over 10 years to build that. There's a link here right above that picture, and that'll take you to a website that's got some more pictures from that project. I'll show you some of his coax run into his shack there, which is rather impressive as well. I urge you, if you have some time, to check that out. Also, the link above that is an article that was done when Joe Taylor and some other notable hams did EME successfully from the Arecibo dish, the 1,000-foot dish at Arecibo on 432 megahertz. That's another impressive article to go look at. So if you have time and you have this copy of this presentation, you can follow these links and check those out. Well, if you want to get into HF portable and change things up a little bit, there's definitely no shortage of HF antennas, that's for sure. There's probably more HF antenna designs out there than any other antennas. And if you're into POTA or Invis or SOTA or IOTA or even WM Plota, yep, you heard that right, WM Plota, that's Walmart parking lots on the air. It's a real thing, and I think Kelly's probably going to get into it after this weekend. Check out their website at wmplota.org. You'll see some pretty interesting stuff there. Anyway, if that's your kind of thing, the HF portable, and you're operating out in the field and you want an antenna that's both quick to deploy and minimally intrusive, you may find yourself looking at simple wire antennas. like some of these that are pictured here. Vertical antennas are a good choice where there's no natural supports for hanging wire antennas from. You can bring those in with you. You can bring simple poles that you can park your tire over with pulleys, and you can bring your own antenna structures. Some areas may not allow you to use natural tree antenna supports, so you got to get creative sometimes. But these lightweight, portable HF antennas make things a little easier. These antennas could also be useful in HOA situations where antenna restrictions prevent other types of antennas from being deployed as well. Multiband versus monoband dipoles. Monoband dipoles are relatively easy to construct, tune, and deploy. These are usually constructed with wires cut to a total length of 1/2 wavelength and use simple insulators. Multiband dipole antennas are usually constructed with the same wire, however, they have a set of elements cut for each band the antenna is intended to operate on. The interaction of the elements make trim tuning a little difficult as each set of wires affect others. Both of these antennas offer good performance. Now we get to talk about beams and quads. If anybody still needs to get me a Christmas present, this antenna here on the top left is on the top of my Christmas wish list. I can send you a link to that website where you can purchase that exact model if you want. I'll send that to you offline. These antennas are directional, and usually they're attached to rotators to aid in the rotating on the fly. A lot of these antennas have so much gain in the direction they're pointing that they have very strong nulls on the side. And this is a product of the RF switching we were talking about earlier. This configuration typically provides for a lower noise floor because there are larger null areas on the sides of the radiation pattern, and then you don't pick up any of the local noise that you would with omnidirectional type antennas. This makes it seem as received signals are boosted because, well, they kind of are. The drawback of these antennas comes because of their size. Mostly these antennas are installed on towers and require very large turning radiuses. Well, if you're IDN, I guess I should too. This is Chris, W5CUY, and we're over in Louise with the Wednesday Tech Net number 2 edition, talking about antennas on the W5 LCR repeater system. Next, we're going to talk about receive antennas. And receive antennas are designed to effectively receive signals, generally over a broad range of frequencies. These antennas are not designed to transmit, and most of the time they will be damaged if used to transmit. The benefit to using dedicated receive antennas is a lot of times they're not susceptible to the same noise issues that your transmitting antennas are. And while they do not have to be, some designs of receiving antennas can be rather large and take up a considerable amount of real estate. The picture on the left here is a disc cone antenna. It's a funny looking disc cone, but it is a disc cone, trust me. And this particular one is designed to receive signals from 320 megahertz to 1.8 gigahertz. 320 megahertz to 1.8 gigahertz. That's quite a span for a little chunk of metal like that. It's pretty cool though. The center picture here is just a simple receiving loop, an elevated loop that's guyed off. And the picture on the right, it may be a little hard to see, but in the green grass there's like a yellow box kind of laid out, and that is a loop. Only problem is it's buried. They're actually really effective on receiving low band. I actually built one and used this at my personal QTH for a while on 160 and 80 meters until I decided to test the transmit RF resistance theory, which is why I can say that it's that way. Don't transmit on your receive antennas. You know, working no more. 75 ohms is the common impedance for dedicated receiving antennas, due to this being the impedance that will cause the least amount of of attenuation. Remember that from the long time ago research? None of all this stuff matters that we talked about before if you can't get the RF from the transmitter to the antenna, right? The most common type of feed line used today is coaxial or coax. Coax is an unbalanced transmission line comprised of a center conductor and a shield. The two of these are separated by a dielectric material, and all of this is encased in a jacketed material. Depending on the type of coax and the frequencies in which you intend to operate, consideration should be given to line loss with coax. The higher the frequency and the longer the run, the better coax you will need. An alternative to coax is ladder line and twin lead. Unlike coax, this type of transmission line is balanced. Balanced transmission lines have the advantage in that they exhibit substantially less loss on the HF bands than any other transmission line. Because of this, you can get away with higher SWRs than you can with coax. This link here on this slide goes to a YouTube channel from a fellow named Stan Gibelisco. I don't know if anybody's watched any of his videos. He is also an SK now, but his videos are still there on YouTube for you to enjoy. And he's got a lot of theory videos, a lot of antenna videos, and there's a lot of material there that you can just kind of gorge out on. There's a lot of good stuff there. So if you go to this link, it'll take you to a specific video where he talks about feed line and the difference between balanced and unbalanced line, but you'll also be able to find some of his other videos which are worth watching. And we can't talk about antennas without talking about tuners, right? Are they magical boxes? I like to think they are, but really they're not. An antenna tuner is not magical. All a tuner does is it matches the impedance of the antenna system to the impedance the transmitter expects to see so that a maximum power transfer can happen between the transmitter and the antenna system. If you have a poor antenna for the frequency of operation, and it does not radiate well, a tuner will not fix that, ever. It'll never fix your antenna. What will happen, though, is the tuner will start to radiate RF energy that the antenna is not capable of radiating. And part of this will radiate as stray RF, part will radiate as heat, and part will possibly radiate as the factory-installed magic smoke releasing itself. I always like to say RF got to go somewhere. If it doesn't go where it's supposed to go, it will go where it is not supposed to go. So remember that. RF got to go somewhere. Take it from me. Get your antenna right, and everything will be happy after that. I promise. All right, that's it. So just to recap, just remember the best antenna is the one that you have to make contacts with. And try not to get wrapped up in tuning and trimming to make everything just so perfect. Making sure everything is extremely tight and all that, because then you're going to spend more time working than you will playing on the radio and using that antenna. Use your antenna, get on the air, make some contacts, and remember that every antenna is a compromise. Have fun playing with some antennas. Real quick, before I turn it back to our net control, I want to thank everyone for coming out and supporting TechNet number 2. To show my appreciation, and after all the late check-ins are logged in, we'll be giving away this book from my personal library. It is a slightly used copy of ARRL's VHF and UHF Antenna Classics book. This book is jam-packed with easy-to-build antennas using designs gathered from the 1980 through 2003 issues of QST. Designs include ground planes, J-poles, mobile antennas, Yagis, and more. Stick around to see who the lucky winner will be selected from the check-in list. Doc, back to you, my friend. W5CUY.
This is KI5SIJ on the W5LCR repeater system with the Crossroads Ham Radio Club's monthly TechNet session. We'd like to give a big thanks to Chris, W5CUY, for that great presentation. We all know antennas is kind of like grounding. There's plenty of information to be discussed, so I look forward to future presentations, a part 2 or so. in the future. But we appreciate the time you spent putting that together and presenting that to us tonight. So at this time, we're going to go ahead and open up the net for any tech questions related to antennas, specific to this topic that we're discussing tonight. We'll take questions first over the radio, and then we'll follow up with questions on Zoom. We can take audio calls on Zoom tonight, I believe, but we're going to call on those over the radio first, and then we'll move to Zoom. So anybody that has any question regarding Zoom, regarding antennas, go ahead and give your call sign. I'm going to write your call sign down, and then we will call on you one at a time to present your question.
I got a question, Josh, K5LK.
Hey, with it. Hey, 5LK, go ahead with your question.
Okay, thanks. Hey, Chris, great presentation tonight. Awesome. Could you talk a little bit about, I think you covered it in slides 7 and 8, antenna modeling, a little bit more. How is that being done today? What type of programs? Is it worth all the effort if you're, just got a regular old in-fed half wave or vertical at your house? Just your thoughts?
Well, great question, Bill. Me personally, I do kind of like playing with antenna modeling myself. Those plots that were there in the presentation, I did on my computer from some of my antennas. I do think it is worth it. If you have really complex antennas, like beams with a bunch of elements and traps and things like that, it's probably not worth modeling. You should probably just, in my opinion, go with the manufacturer's model if you want to see what that looks like. But yeah, it's kind of fun. It's a different process to learn. There's a couple different softwares. I'm trying to remember the name of the one that I had here. I had it pulled up, and then I can't see that while I'm scrolling, of course, for some reason. But yeah, the software does not come with a manual. It's like free, like everything else. So there's a learning curve with the particular software that I've used. I don't know how some of the other ones are, but there's probably plenty of YouTube videos and enough stuff out there. I could draw up some simple stuff. I think if we wanted to get complicated, it'd be a little different story. But yeah, I think antenna modeling is great. You can look at the near field, far field. You can see your gain numbers. You can do different things in that modeling. You can raise and lower the height a little bit. You want to drop one side and see what that does to your radiation pattern. You can change frequencies, check SWR, all that kind of stuff with the software. So it's pretty intuitive. Just remember, use the antenna at some point too.
Yeah, and I put a link in the chat to one that I've used in the past. I believe that's the one that I used a while back whenever I was testing some stuff out. If I'm not mistaken, if that's the right one, that one's free as well. They got DX Engineering did a video on how to use that particular one. So if anybody wants more information on how to use the modeling software, there is a YouTube video. The DX Engineering guy goes through this particular software and shows you how to use it and how to model an antenna. So it's a good thing to learn. I've messed with it very little, but not enough. Hey, Chris, if you don't mind, talk a little bit about, I'll ask a question. Talk a little bit about buried listening antennas. It's something I've been researching for about 3 or 4 weeks. I know the military use them a whole lot, but I want to bury one specifically for listening. Do you mind sharing with us your experience with the one that you messed with?
Yeah, I don't mind at all. And to answer the antenna modeling question, Ben got it right in the chat there. The Easy Nick. That's what I use. So thanks, Ben, for helping me with my amnesia there. Yeah. So that is. There's a loop on the ground, LOG, loop on ground, but there's one step farther than that. So a loop on the ground, between that and a beverage, you're suffering a little bit of difference in the receive, putting it on the ground, but burying it actually a couple inches below the surface. What I did here, it worked great. I compared it to a sloper antenna that I had up at the time as well, and I could hear everything the same. It was a lot quieter. There was not nearly the amount of atmospheric noise that I was hearing on that antenna on the lower bands compared to the other one, which makes it for a much more pleasant listening experience if you're listening on the lower bands for a long period of time. You're not listening to as much static or atmospheric noise, but I did not hear any stations on there that I did not hear on antennas that I had above the ground. It's not like it was some kind of special secret weapon, but the biggest difference that I noticed was the difference in the noise floor. Does that answer your question, Josh?
Absolutely. So that kind of goes in line with some of the observations I made when I was messing with the Invis antennas. I noticed that the lower to the ground that the horizontal antennas got, the quieter the noise was, and it made it easier to hear the stations I could already hear. I just didn't fight all the atmospheric noise as bad. So I guess if that's the case, that may work out for what I'm trying to do. I'm just trying to figure out how to get a good listening antenna up, an alternate listening antenna up other than the one that I have, that will survive a lawn being mowed. So putting up an Invis antenna on fence stakes or fence posts doesn't work too well when the yard guys are coming every 2 weeks to mow or every week to mow. So putting one an inch or two underneath the ground, or I've seen some guys actually just lay it on top of the grass right after a fresh cut, and over a couple of weeks as the grass grows, it'll grow on top. So that's an option too instead of burying it. Just got to make sure your feed cable's buried though. But all right, well, we'll open it up. Anybody else on the air, on the RF, that have any questions regarding antennas, go ahead and throw your call sign out or pose your question, either way. And we'll see if we can get some answers for you.
W5ITZ.
K5TTF.
All right, we'll start with Bill, W5ITZ. Go ahead with your question, buddy.
Well, good evening, Josh, everyone else out on the Tech Net tonight. Chris, great job. You did your homework and you put together a really great informal presentation. I was wondering if you had a ballpark figure of what a brand new amateur could expect to spend to build simple homebrew antennas. For example, maybe a single band dipole if you're wanting to start with HF, or maybe even a quarter wave ground plane VHF or UHF antenna. Do you have a ballpark figure of what type of investment someone would have to make to put one of those together and get on the air?
Well, that's a great question, Bill, and I should have included some of that information in the presentation, but I had to draw the line somewhere, otherwise I'd still be on slide 3. I would say if you're looking maybe HF and you're wanting to build a single band dipole, I mean, you just need some wire, and you don't even have to buy insulators. All kinds of cool stuff is your friend when you're working on a budget. I would say maybe $4 or $5 is what you're looking at for a monoband dipole, and for like a quarter wave ground plane, something like that, maybe just a little bit more because of the connector. But if you are on here and you're part of this group and you have access to our email system, then I do not think that you will find any shortage of people willing to throw stuff your way if that's what you want to do and you're on that kind of a budget. So there's that piece of information as well. But you can get away with doing all that kind of stuff, the quarter wave ground planes, especially on VHF and UHF and monoband HF dipoles for very relatively inexpensive.
Very good. All right, so very inexpensive to get started and get on the air. Thanks, Chris. This is W5ITZ.
Yeah, one of the quickest ways that I found, especially when you're trying to do POTA, is one of them little BNC to banana clip adapters. I think you can get 3 or 4 of those on Amazon for about $10. And a 50-foot or 100-foot spool of speaker wire, man. And that's really all it takes. You got to have some feed cord though, but yeah, as far as an antenna, it don't take much. It takes probably more desire than it does parts. But well, let's see. I heard K5TTF out there with a question. Go ahead.
Yeah, this is K5TTF. Chris, that was a pretty decent presentation. I appreciate it. Although I've kind of set in my ways, if you know what I mean. I like a certain type of antenna, and I'm going to. Anyway, my comment more than question is that I have tried a lot of things in the past 60 some odd years, but I have had problems with that fan dipole that you showed, one slide of there. I could never get it, and I just had a 40 and 75 meter fan dipole, but I had the 40 meter underneath 75 meter, and it didn't work. Well, it worked, but I'd adjust the SWR on one, and I'd adjust it on the other band, and then I'd go back to the first, and wound up chasing my tail. So I gave up on it. Unfortunately, at that point, I decided it would be a good idea to buy traps. And that only gave me about 30 kilohertz of bandwidth on both 40 and 75, so I didn't like that either. I've gone an entirely different direction now, but I had a very hard time with that fan dipole. And my third thing, I guess, is that you should put a better, bigger page number on your slides and refer to page number as opposed to this next. And you see this, I kind of got lost a couple of times because I wasn't keeping up with you. K5T.
Well, thanks for those comments, Bill. Thanks for being a member of the audience and participating tonight too. I really appreciate it. Yeah, the page number thing, I apologize for that. I didn't even know you could put page numbers on your slides until I turned it in, and then I found out you could. So I was completely enthralled in that. I didn't even dig down farther to see if they could be bigger for people that needed them to be a little bit bigger. So I apologize. I'll take that for next time. And yeah, fan dipoles, they are not my favorite things to mess with either. That's why I don't have any up here. I tried it twice, and it was not fun. And ham radio is supposed to be fun. My Elmer told me that early on. When it starts not being fun, put it down because it's supposed to be fun. So I don't know. Maybe turn it into something else like you did, or you can take those elements and separate them if you have the capability to run that antenna with like the 80 meter elements running north and south and then the 40 meter elements running east and west, or offset them a little bit. That'll keep them from interacting with each other so much. But that, yeah, the more bands you have on a fan dipole, the harder it is to try to get it all tuned and happy. But thanks for your questions and comments, Bill. Thanks for being there.
Anybody anybody else have any questions? This is KI5SIJ, the net controller for the Tech Net session tonight. We're open up for questions regarding antennas. We're looking for anybody else to have any questions before we move over to Zoom.
Kilo India 5, Hotel Victor Foxtrot.
Go ahead, Darren. Go ahead with your question.
So what determines the impedance of a particular coax? 75 or 50 or all the other flavors?
So that's a good question, Darren. And it's important to look at the manufacturing specifications for coax. Some of the 75 ohm stuff is very similar size to the 50 ohm stuff, but it's not exactly the same size, and that's where the impedance difference comes from. So the difference in the dielectric material or the dielectric material size, which affects the relationship between the center conductor, the distance between the center conductor and the inside of the shield. That's really where they get a lot of the impedance difference from on the different types of coax, is the size and the size relationship, or the size distance between the interconductor or the center conductor and the inside of the shield.
All right, I appreciate that. Yeah, 5HPF, back to net.
Anybody else have any other
WFBSA
questions
with
regarding
comment.
antennas on the air?
I heard W5BSA out there. What you got, Joe?
Great net. Great job, Chris. I was just there was a really interesting article in this month's QST. It was talking about the difference, especially on wire antennas, when using copper compared to aluminum. Quite a few good details and interesting facts to learn about.
Great, thanks for that information.
Well, good evening, Joe. Thanks for your comment. Yeah, well, I'll have to check that out. I have the latest issues sitting on the front seat of my work truck, and I opened it up long enough to look at all the field day stuff, and that's it. So I'll have to look into that. But I think that'll be an interesting read for me. I really appreciate that. Sounds like a good one to check into.
Well, thank y'all for that information. The floor's still open if anybody else has any questions.
AG5IAZ.
Go ahead, Jim.
It's not a question, it's a comment, and that is, if you're going to be fooling with antennas, you got to find out where you're at and which way you need to go on adjusting, and really kind of evaluate what's going on with the bandwidth of the antenna. And I would just suggest to anyone to get one of the Nano VNA vector network analyzers to start with. And they have one of them that has N connectors, which is easier to work with and more durable than the one with the SMAs. But for $100 and something, it's a fantastic value. And learn how to use the software for your computer, where you plug the VNA into the computer. It's a much easier way to work. But anyway, you'll build antennas and you don't really know how good of an antenna it is as far as the tuning of it until you put it on a VNA, and then when you make your adjustments, you can see the change. So anyway, that's a suggestion for people as they grow with their antenna building.
KB5 PBM with a question.
Thank thanks for that information, Jim. Yep, having one of those is most definitely helpful. And KB5PBM, go ahead with your question.
Yeah, Chris, this is one question I have. I know you'll have the answer to it because you helped me out with it. But when do you use a balun and when not to use a balun? I guess that's what antennas and when do you use them, when not?
That's another good question, Robert. And I hope somebody's taking notes in the background because you guys just see everybody look up at me now. We're taking notes and stuff for future presentations because there's only so much you can fit into one. But yeah, balun. So the name balun, think balanced, unbalanced. Balun, balanced, unbalanced. So if you have a balanced antenna and you're trying to use a balanced feed line, you don't need anything because you've got balance to balance. But balanced to unbalanced, like if you had a dipole, a regular center-fed dipole that's a balanced antenna, and you're trying to feed it with an unbalanced transmission line such as coax, that would be a perfect application for a balun from balanced to unbalanced. And that gets really deep in theory, and I really want to maybe visit that in detail in one of the future presentations. But that would be the perfect application for a perfect answer to your question that I can leave it there is a balun is used when you're matching a balanced antenna to an unbalanced feed line.
Thanks, Chris. I appreciate it.
All right. Anybody else have any questions? If not, we're going to move to Zoom. All right. For anybody that's on Zoom that can hear me, if you have a question and you'd like to present your question through Zoom, just put in the text box that you'd like to pose a question, and we'll pipe you in through the repeater system there. We'll be asking for questions there on Zoom, and we'll be asking for general questions as well that are related to anything ham radio related. So anybody else that has a question on the air or on Zoom, go ahead and let us know, and we'll get your question posed. There's no more questions. We still got a few more minutes. If there's any questions, they don't have to be antenna related now. If you just have any radio related or amateur radio related questions, feel free to call up over the air or through Zoom, and we'll get you weighted on there and get your question discussed.
K5T.
K5TTF, go ahead.
Well, this is not for Chris, but it's for maybe one of the Tech Net members or Tech Net board, whoever they are. Why are we being, quote, why do I need to Zoom? I've got a good ham rig here. Why can't I do everything you're going to do with my ham radio rig? Or
oh, you absolutely can join over your radio. The Zoom gives us a way to share out the digital presentations like Chris did tonight. Other than hearing the audio side, there's not a way to visualize it. So we do the Zoom sessions so that we can share out the presentations. Don't necessarily have to talk on Zooms. But it's great to be able to follow along with the presentation. So when you log into Zoom, the presentation that's being discussed will be displayed on there, and people can see where we're at on the presentation and follow along. That's really the only added benefit, and the chat room's open for conversation after the net as well. So hopefully we answered that for you there.
Not a very good answer. I was only able to follow the presentation with the copy that was emailed out to everybody. So I have the presentation here in front of me, and I went right along with it without a problem. I just I'm wondering what I'm meaning by not having Zoom over.
Really, the only thing you're missing is just being able to see the presenter present his screen as he goes through the presentation. Really, that's the only part there. K5LK, go ahead.
Yeah, good question. I think we're going to Zoom a couple other reasons for third party folks that maybe don't have their ham radio license yet. They can get in, learn more about the hobby, the technical side of it. Also, we're recording this, putting it up on YouTube, and so the presentation follow along for people that can't make the net live tonight. That's probably another reason. So, to each his own here, but I think we're trying to open it up to a wider audience. Back to net control, then I've got a general question. K5LK.
W5BSA, I have a follow-up question on the Nano VNA.
All right, hopefully we got that explained. So yeah, we are recording the Zoom sessions and using that video to post for those that cannot make it tonight that would like to see the session. They can go and watch it at a later date and time from the Tech Net webpage, which is hosted on YouTube there. The videos are hosted on YouTube. So let's see. K5LK, I know you had a question, then I heard a question out there about the VNA. So let's go with K5LK with your question, and then we'll call on the question about the VNA.
Well, I've got more of a general question, Josh. If you don't mind, let's turn it over to Joe, W5BSA, because I'm sure he'll have a great question.
All right, go ahead, Joe. Go ahead with your question there about the VNAs.
Thank you. Well, I heard there's one that's at $50, and then I heard one is over $100, and I heard what he said about the end connectors, which certainly makes sense. But my basic question is, I've heard some really good things about it, but can you give me a quick overview of exactly all the things that it will do? I know I guess the generic term is antenna analyzer, but I'm assuming you can check SWR. But what else can you do with it?
Josh, this is KG5IAZ. Do you want me to address that question?
Go right on. Yeah, I have a VNA, but I have never used it. I always tend to go to my rig expert. But yes, please go ahead and answer that question.
Okay, so when you have an AC signal, like the radio RF signal, the transmitter is looking for the characteristic impedance of 50 ohms. And so that impedance consists of resistance and capacitance and inductance. And those three values combined determine the impedance of the antenna. So a vector network analyzer looks for and determines that vector of the resistance, the capacitance, and the inductance for whatever particular frequency range you put through it. And so your antenna wants to be for 50 ohms. So when your SWR is off is when you're not at that 50 ohms impedance. So what this allows you to do is put in a frequency range, for example, 140 megahertz up to 150 megahertz, and then test your antenna, and it will tell you how close it is to the 50 ohm impedance. throughout that whole range, and it's never going to be exactly 50 ohms for the whole range of it. It's going to vary, but it will give you a graphical representation. You could do the same thing with an SWR meter, sort of, as far as determine the SWR, but you'd have to plot the little points out with a piece of paper. This thing does it for you on the screen of the VNA, and it helps you determine if the problem is capacitance or inductance of why you're not at 50 ohms. Really, a good discussion on VNA is not something that can be a single answer. It could be a whole tech net by itself, which is the suggestion for the team.
Thanks very
Did
much.
that help?
WSA. Let me ask you this quick follow-up on that. I've been told, because I have a problem at a repeater site with coax possibly, but I've been told that maybe with the VNA, if you have a problem with the coax, somehow it can tell you where that problem might be located along the length of the coax. Does that make sense? And is that, from what you're understanding, is that possible?
Absolutely. One of my VNAs allows you to do what's called a time domain reflectometry, where it shoots the signal out, and over time, over the distance, it looks for what's reflected back, and it can find a bad connection at a coax adapter, for example, or a crimp in the actual coax. We had some hardline, some coax that was dented in shipping for the Bay City repeater, and I measured it with the tool, and it was like, oh, about 45 feet. We took a tape measure, measured out about 45 feet. There was a dent, and I made a special tool, a dedenter, that made the coax round again and fixed the impedance right at the coax. So Chris mentioned 50 ohm coax and 75 ohm coax. If you damage the coax, then it moves away from the 50 ohms. And we were able to determine with this tool how many feet down the coax the dent was, and it might have gone to 45 ohms, and then by putting this dedenter on it, we were able to bring it back closer to 50 ohms. So yes, that tool is called a time domain reflectometer, or a frequency domain reflectometer is another mathematical method to do that. But yes, that's built into some of the VNAs, if that helps.
That's exactly the info I was looking for. I got to get me one.
Yeah, 5 HPF for the comment or question.
Go ahead, Darren.
So Jim, I'm curious because I've been studying that aspect of nano VNA as well. But it doesn't just actually like give you that information. Isn't there some mathematical formulas you have to go through with information you receive from the VNA to be able to determine the length of the distance where the connector or damaged portion may be?
Okay, let me go back and qualify my answer on the time domain and frequency domain reflectometer. I have 3 different kinds of VNAs. One of them is the single port VNA that has the time domain reflectometer. I have the nano VNA, and I've never experienced or played with any time domain reflectometry capability of it has, so I'm not going to tell you that it has it. I don't know. And my third one is a Siglant, which is a spectrum analyzer and VNA in the same unit. And I have played with that on this. So I don't know the nano VNA does the time domain reflectometry. Over.
Okay, I appreciate that. Yeah, from just like I said, just some brief study on it, trying to figure out that aspect of it, because I know the nano VNAs have capabilities to give you information, but I think you then actually have to do some math, which is relatively easy if you build a spreadsheet or write it down and use a calculator or whatever. It'll tell you what the distance is, but it is I guess just because of the cost of them and how they're built, I think you do have to do a little bit of work on your own to figure out what that distance is. Okay, KI5 HVF back in that.
Chris, do you have any comment about the nano VNA and a TDR function?
Nope, I think you covered it very well. I think it's also noteworthy saying though with the VNAs, mainly what I use my VNA for is filter work. I mess with a lot of filters, and they're extremely useful for that type of work as well too. So they're pretty powerful tools. But I mainly use mine connected to my computer on the workbench. So there's that too. W5CUY.
Good discussion on the VNAs. Very good discussion. Is there any other topics out there that anybody would like to pose or question we'll discuss before we close up the net?
K5LK, I just had a general question, Josh, about operating for the club. Anybody on the net tonight?
Absolutely. Go ahead.
Yeah, I got to be careful how I phrase this, but Black Friday I bought a Yaesu FT710 field. They had just really good prices on it because I want to start operating more HF portable. I know Darren and I at KI5 HVF talked about that a little bit, but are there any other folks that are on tonight that have been doing some HF portable? And just maybe give a quick overview of antennas and kind of what's going on around here in Southeast Texas. I think some great parks to operate in. So I'd just be kind of curious. We got time, Josh.
Absolutely. If anybody wants to take a stab at that, anybody doing that type of work, go ahead and come up and answer the question. I know I've done POTA a couple times. I've really enjoyed that. I'd love to see if maybe one weekend a bunch of us guys that'd be interested in doing an event together, maybe all show up in a park together for a couple hours one weekend and go work POTA. Some of the other clubs are doing that. Man, don't have to be every month, but maybe every couple of months if we feel like getting together. That would be real fun. But yeah, if there's anybody out there that'd like to take a stab at answering that question, go ahead.
Well, I'll tell you what I use. But the only thing I'm lacking to make it totally portable is a power supply. So when I've done this, I've had my RV with me, and I've actually used the batteries on the RV versus dragging a power supply around because I did have 120 volts available to me, but I didn't want to drag around. The whole thing I got the 40 amp triple light power supply, so I powered it off the RV batteries. Any car battery would work to get you going. Anything with decent amount of amp hours could serve you for a few hours anyway. And as far as the antenna, I have several. The one that I have used last is basically a 17-foot telescoping antenna that I built I have a piece of flat bar, put a spike on one side and drive it in the ground, telescope the antenna, and then I have wire radials that just lay down on the ground. And so I'll use that as a vertical. I also have a single band cut for 40 meters that I can use. I can either string it up in the trees or I can string it up down low as a NVIS style antenna. So I've also strung, before I had my telescoping antenna, I strung a wire straight up, over a tree limb and hung it down to the ground and had radials off of it. So, and I just used my ICOM 7300 because it's the only HF I have. So I packed it up and I bought one of those boxes from Harbor Freight that has the pluck out foam in it, and I made my 7300 fit in that. And I have another tote that has all my coax and wires and and I bring my Nano VNA with me just in case. I bring my rig expert with me, and just a box full of stuff to set up in the field, and don't use half of it, but I got it just in case I need it. That's kind of mine in a nutshell, but anybody else, I'd be glad to hear it as well, so if anybody else has anything. CRHRC Tech Net.
Question for him.
This is KJ5ADO.
Go ahead, Brenda.
I'm kind of new into the whole POTA thing, but I also have a 7300 that I take with me and have the same box from Harbor Freight. And I use a telescoping, also 17-foot antenna that's on a tripod. And it also has a coil, too. So I can adjust it to different lengths and get on different bands, and I've been very successful with that. I use I have a Bio-Inno battery, and then I have a nice battery that I got in the raffle. So that's what I use, and it works really nice for me. KJ5ADO, back to net.
Oh, very good deal. Very good deal. And I thought I heard somebody else out there about the same time, Brenda, keyed up there, but let's see. We got a couple messages on Zoom. Let's see. One says from Evan, KG5ZZA, use a Wolf River coil and a Wolf River 20-meter whip for POTA. Also use a 40-amp-hour Bio-Inno battery. And then Ben said, been a member of a half a dozen clubs. Let's see. Unfortunately, lived too far. I got you. Okay. So let's see. If there's anybody else out there got any questions, go ahead and give them out there. I'll go ahead and tell you what I use. I have a FT891 Yaesu mobile style radio. With the last time I ran it, I ran it on a 20-amp-hour battery, and I just used a off-center fed dipole, 10-meter through 80-meter off-center fed dipole up about 20 foot, and that was about it for me. And I made a few DX, but made a lot of local contacts on it because it was more Emvis than anything. But if anybody else wants to chime in, go ahead and chime in.
A BSA with a question for Brenda. On the 17-foot telescoping antenna, is that the MFJ?
The KJ5ADO. I got it from Wolf River, but it probably is one from MFJ.
This is KF5HBF. I got mine from AliExpress for $23 or something like that. Took me two shipments to get it. The first one came with this empty cardboard tube with one piece of shipping tape over the end of it. It looked like somebody slung it, and the threads were bare on the end of the antenna, and it got right through the tape. So they did get me another one though, but for $23 it was worth it.
I don't think mine was probably much more than that. The coil was probably the most expensive part. And ironically, I don't use it as much as the antenna by itself. I like it better.
Are quite a bit more money than the VNA, so why would you need both of those? Does the rig expert use it for something special that the VNA won't do, or just curious?
Yeah, we had a slight double there. I think the question we had there was, what was the need or the difference between using a rig expert and the VNA? Why would you need both? Anybody want to take a stab at that?
IAZ.
Go ahead, Jim. You got it.
I think a Nano VNA has a really tiny little screen and you have to calibrate it for every frequency range you use. A rig expert is just a lot easier to use. Maybe Robert could come on that too.
So I wanted to ask a question about that, just based off of what we were hearing earlier, though. Sounds like, unless I misunderstood something, it sounds like the VNAs or the nano VNAs provide a little bit different functionality than what the rig expert does. Is that true?
Yes, but again, it's my just my feeling that the rig expert is easier to use than the nano VNA because of its form and its size and the size of the screen and the layout of the buttons and the way that you use it. And I just have a hard time with the nano VNA because my eyesight's poor. I like to use a computer with it. So, but that's just some thoughts on it.
Okay, perfect. Well, yeah, I'll tell you what, that sounds like that might be a good topic for us to make another Tech Net on, because it seems like there's a few questions still remaining about that out there. If there are any other questions, we'll do one last round here for questions, and then we're going to go ahead and wrap it up. Is there any other questions out there that we'd like to pose tonight on the Tech Net before we set it down? All right, well, with nothing heard tonight, we've had a great discussion about a variety of different topics, but it all seemed to still stay based around the antenna somehow. So VNAs and rig experts and underground and above ground antennas, and well, even the one that Chris wants us to buy him for Christmas. What do y'all think about that? So let's see where I'm at here. Sorry for this. Still trying to figure out where I'm at in my place here. So I guess at this time, what I'm going to do is I'm going to go ahead and ask for late check-ins, and I'm going to go ahead and call through the existing check-ins we have, just so that those folks know that they're already checked in, to confirm that, and then we'll actually open it up for our late check-ins. Give me 1 second to find my place. All right, so before we do that, let me go ahead and just say this. We're going to go ahead and start wrapping up tonight's Tech Net session. If you have any questions regarding amateur radio related topics, or have any topic suggestions for any upcoming Tech Net sessions, please feel free to shoot those over to us by emailing us at technet.crhrc.org. Again, that's technet@crhrc.org. All right, before we're closing that, as I previously mentioned, I want to give everybody an opportunity to get checked in. If you have not already checked in through pre-check-in on Zoom or NetLogger, then now is your opportunity to do so. To get checked in, I'll ask that you give your call sign slowly and phonetically twice, and we'll go ahead and do that now. So what I'm going to do is I'm going to go through the list real quick, and then we'll have everybody call in. So I'll start at the top. All right, we got Kilo 5 Tango Foxtrot, Kilo India 5 Oscar Lima Golf. We got KJ 5 CAP. We got Don KD0NN. We got Daniel KJ 5 DCD. We got Scott KC5 RXW. We got Phil W5 CPO. We got Kelly AE5II. We got Chris, the presenter for tonight, W5CUY. I'm going to let the repeater drop. All right. right. So yeah, we ended with Chris, W5CUY. Then we got Bill, K5LK. Myself, KI5SIJ. Got Darren, KI5HVF. Got Bill, W5ITZ. Got Nathan, KI5YOL. Got Robert, KB5PBM. Got Brian, N5TZV. Got Rick, WB8FVB. Got, let's see, Richard, K5RBC. We got Thomas, KI5OMW. And we got Brenda, KJ5AD0, or ADO. We have a few more, so we ended with Brenda there. All right, and then the last 5 or 6, let's see, KD5PMU, that's Noel. Then we got Evan, KG5ZZA. Then we got Ben, NE5B. We got Jim, KG5IAZ. We got Brian, KI5UZY. Then we got W5BSA, Joe. And then what we'll ask is that if you did not hear your name called, it means we do not have you checked in. At this time, I'll ask that you give your call sign slowly and phonetically twice, followed by your name so we can get you checked in. If you'd like to get checked in, late check-ins, go ahead and please give your calls. You can give your call now.
KJ5DR.
Kilo 5, Bravo, Lima, uniform.
Kilo
5, Bravo, Lima,
5,
uniform.
Delta.
Lee, Pasadena.
India, Romeo. Linda.
Linda, give your call sign one more time.
Kilo Juliet 5, Delta, India, Romeo.
Kilo 5, Bravo, Lima, uniform. Kilo 5, Bravo, Lima, uniform. Lee, Pasadena.
Right, we got y'all in there. I appreciate that. And let's see, anybody else? Go ahead and give your call sign now, slowly and phonetically. I think everybody's died now. If there's any other station out there that'd like to get checked in before we close out this month's session of the Tech Net session here, go ahead and give your call sign now.
Get in on the list so you can get in on the drawing. W5CUY.
That's right. If your name's not on this list, your name's not up for drawing for this book. So we'll do one more last call. This is late check-ins on the W5 LCR repeater system for the Crossroads Ham Radio Club December session of the monthly Tech Net session here. Taking late check-ins. Give your call sign slowly and phonetically twice to get checked in. All right. Well, not hearing any others, we'll go ahead and shut her down. So tonight's winner is number 5. Number 5, line number 5, is the winner of the book that Chris has given away there. Number 5. That looks like that's Daniel, KJ5DCD. You're the lucky winner for tonight's giveaway from Chris, W5CUY.
This is KJ5DCD. Thank you very much, guys. You know, that's awesome. Exactly what I needed.
Cool deal. Well, if you'll get with W5CUY, I'm sure y'all can arrange getting that swapped over from hands to hands, and we'll go ahead and proceed on. So we're going to continue wrapping up tonight's session. If you have any questions, as I previously mentioned, please feel free to send those to email, technet@CRHRC.org. I want to thank everyone that participated in tonight's TechNet number 2 session. Also, we want to give big thanks to all the TechNet committee members who helped in making tonight's net a success. If you have any questions regarding the TechNet or would like to join the TechNet committee, you can send an email to technet@CRHRC.org. We can use more volunteers. We can use more volunteers. So if you'd like to help us continue supporting this monthly TechNet session, please feel free to reach out to us, and we are sure we can get you plugged in somewhere in some capacity. Finally, please note that several of us will be remaining on the Zoom session tonight for General Rag 2. I'll go ahead and close this session of the Crossroads Ham Radio Club's monthly TechNet. This is Kilo India 5, Sierra India Juliet Joshua and Manville returning the repeaters back to normal amateur radio use. Good night, all.